Alright, I'm making this particular video to explain a bit on the exercise that I gave to you, because I saw a few of you get a bit confused by this case. Alright, let's try to read the question. So it's a uniform rigid bar. Okay, length is 2.4, so total length from end to end is 2.4. Is uniform, so the weight supposed to be acting in the middle. That's the weight. Okay, it's pivoted horizontal at its midpoint, so that's why that's the weight here, and that's the result, the reaction force here, R. Okay, both of that we can ignore. So ignore in our solution. Weights are hung from 2 points of the bar as shown in the diagram. So there's a 200 Newton on the left hand side and 300 Newton on the right hand side, and distance is given. To maintain horizontal equilibrium, a couple is applied to the bar. Okay, so to maintain horizontal equilibrium, a couple is applied to the bar. So this couple basically is not shown. It's not shown in the diagram above. You need to apply that so that it maintain equilibrium. That means that with the 200 Newton and the 300 Newton here, it should cause a net moment. Okay, it should cause a net moment, and you found out that this one give you a 160 Newton meter because of 200 times the 0.8, and the 300 Newton is because it multiply by 0.4. 300 multiplied by 0.4, it gives you 120 Newton meter. So you can say 160 is larger than 120. That's why it shouldn't be balanced at first, and it should give you a 40 Newton meter. So most of you are able to find the 40 Newton meter, and you notice that that's an anti-clockwise, but that's the net moment. So the 40 Newton basically is the net moment. Okay, the 40 Newton basically is the net moment. So this net moment is anti-clockwise. Alright, so we have a net moment that is anti-clockwise. If you want to balance this, what you need to do is you need to apply another 40 Newton meter, but in a clockwise direction, and then you cancel the 40 Newton meter in the anti-clockwise direction. And then the question is asking you about this torque and this couple. So basically they are asking about the one that you should apply in the clockwise direction to balance the net moment. So of course the answer is 40 Newton meter in terms of this magnitude, but the direction must be clockwise. Some of you write anti-clockwise, and that is actually not correct. Yeah? And then the second question asks you, if you apply that, so that's the question here. Hold on, what is the magnitude of the force, either one of the force of the couple that need to be applied if the force is to be applied at both ends of the bar? So now we know that if you were to apply the force, it should be at the both ends. So we draw the couple in such. Okay, and by definition of the torque will be F times the whole length, which is the 2.4. So that is of the couple times the 2.4. The 40 Newton just now we will sub into the torque, and from here we can actually find the F. Okay, so that's some clarification for this question.